At this point, we've discussed 4 different reaction types: SN2, SN1, E2, and E1. Now we need to be able to differentiate between when each of these reactions will happen. The easiest way to do this, for me, is to look at the substrate first. If we have a primary substrate, we can actually eliminate a couple of the options. A primary substrate cannot undergo a stepwise mechanism because it would make a primary carbocation. So for this case, we can automatically rule out SN1 reactions and E1 reactions. So now what we need to do is compare the reagents for an SN2 or an E2 reaction. In general, SN2 reactions require a good nucleophile, while E2 reactions require a good base. How do we determine which of these is which? Well, a good nucleophile is generally larger, so the electron cloud can shift and generate more electron density at one area, and then that can act as a nucleophile. So ions like chloride and bromide and iodide, which are all very polarizable, are good nucleophiles. So is sulfide or even H2S. Sulfur is larger than oxygen, for example, and is more polarizable, so you can have more nucleophilicity associated with it. For E2 reactions, you want to look for a good base that's not nucleophilic. Some examples of non-nucleophilic bases are hydride, or DBU, or LDA. We've talked about these before. These are good examples of non-nucleophilic bases. So what happens if we have a nucleophilic base, something like hydroxide? Where does that go in all of this? Or methoxide, for example. In this case, these are relatively small molecules, so they're going to go on the side of SN2 reactions. They can act as both nucleophiles and bases, but because of their small size, they're going to favor SN2 more. On the other hand, if we make these bulkier to the point where it's not realistic for them to act as nucleophiles, we'll shift to an E2 mechanism. So, for example, tert butoxide. Because this is a tertiary base, it's a lot larger, it's a lot bulkier, so it won't be able to fit into the backside attack that we see with SN2 reactions. Now let's take a look if we have a secondary substrate. This is the most complex example because secondary substrates can actually follow any of these mechanistic pathways. So let's refresh what we learned from the primary substrates. SN2 requires a good nucleophile, which means an SN1 reaction will rely on a weak nucleophile. E2 reactions require a strong base, while E1 reactions are going to involve a weak base. So if you're faced with a problem where you have a secondary substrate, take a look at the other reagent associated with that reaction and determine which one of these 4 it is. We went through the strong nucleophiles just now with the primary substrates. An example is sulfide, S-. A weak nucleophile would be something like water. It doesn't have a charge, it doesn't have large polarizability, so the electron density is pretty localized to the oxygen in this case. Unfortunately, and what makes this a little bit more complicated, is that weak bases are the same as weak nucleophiles. So an E1 reaction might also occur if you have water. In the case of strong bases, like we talked about before, an example would be hydride. But when we shift to a secondary substrate, all of the oxygen bases will also function for E2 reactions. So to summarize this, if you have a good nucleophile, it'll be SN2. If you have a weak nucleophile or a weak base, we can have either an E1 or an SN1 reaction. And if you have a strong base, it'll undergo an E2 reaction. Finally, let's take a look at tertiary substrates. For a tertiary substrate, which is much more bulkier, we can automatically rule out SN2 reactions because a nucleophile will not be able to fit into a backside attack pathway, which leaves us with SN1, E2, and E1. Again, let's take a look at the reagent. SN1 reactions require a weak nucleophile, same as a E1 reaction requires a weak base. Again, our example here is something like water or ethanol. These are weak. For an E2 reaction, you'd look for a strong base. So this is actually pretty simple, because if it's a strong base, it'll be an E2 reaction. If it's a weak base or a weak nucleophile, it'll be an SN1 or an E1 reaction. Both of these mechanisms are possible, and you'll actually see a mixture of products.